Well, it's good to be with you this evening, and I get to speak on my specialty topic of astronomy. That's what I got my doctorate in, and that's what I research at the Institute for Creation Research. We have a number of different researchers there studying geology and biology and physics and so on. And I want to show you this evening that astronomy reveals creation. And astronomy is one of those fields that has been used to challenge the Bible. You've heard people say probably that, well, the Bible can't be true because of what we learned about, the Big Bang and astronomy and things like that. But I want to show you that really, when you understand the cosmos, it confirms what the Bible teaches. There are secrets to be revealed in the cosmos that confirm biblical creation. I'm going to cover 5 of these this evening. And you can use these in conversations with people to, lead them toward the gospel, really. And that's what we're all about at the Institute for Creation Research. It's not just an academic debate on origins. We specialize in origins, but we want to see people saved, and that's why we do what we do. We want them to have confidence in the Word of God. We're going to see that the Bible's right when it touches on the fact that the glory of God is revealed in the heavens. The Bible is right when it speaks about the basics of astronomy. The Bible's right when it speaks about the age of the universe. The Bible's right when it speaks about the uniqueness of Earth in the universe. The Bible is right when it touches on distant starlight. And so those are the 5 areas I want to touch on this evening. And so let's start with the glory of God being revealed in the heavens. That's something that the Bible teaches us. In Psalm 19:1, the heavens declare the glory of God, the skies proclaim the work of his hands. And there are a number of ways in which the universe displays God's glory, and it really reveals his character. It's quite wonderful. I want to concentrate just on 2 because I can't hit all of them, obviously, but I'm going to show you that the size and the beauty of the universe are certainly consistent with the mind of God and not just sort of a chance explosion or rapid expansion or what have you. Let's start with the moon. This will be the smallest thing we look at. The moon's about the size of the United States. If you were to put the United States up at the same distance as the moon, it would cover about the same area in the sky, just to give you a feel for how big it is. The moon is a wonderful object to observe in a small telescope or even in binoculars. It's just lovely. In a small telescope, especially when it's in the first quarter phase, you can just see the craters and the shadows of the craters. It's stunning. It's really amazing. And we do a number of, I do observing sessions with folks where I show them the moon through telescopes, and it's a lot of fun. Sometimes people will say, well, can you see the flag, that the astronauts put there? And, well, when you consider it's as big as the United States, that's going to be a little tricky. But because we have a spacecraft orbiting the moon and taking high-resolution images of the surface, we can now see where the Apollo astronauts landed. Isn't that interesting? I'll show you this. This is kind of amazing. But this is for real. We've mapped this very, very accurately, very precisely, and you can see there's the Apollo 11 landing site. Remember when they launched off the moon, they left the lower portion of the spacecraft to save fuel. So that leg, that spider-like looking structure, you can see it there. That's it. That's the lunar module, the lower section of it. And those little dark streaks that you see there, those are the footprints of the astronauts as they walked over to that crater and back. 40-year-old footprints. There's no weather on the moon, so they're not going anywhere. But isn't that amazing? And so we actually have, we can actually see that now and they've imaged all the other landing sites as well. And with the exception of Apollo 11, I'm happy to report that all the flags are still standing. Apollo 11, the flag blew over when they launched because they put it too close to the spacecraft. So it's not standing anymore, but all the other ones are still there. So pretty amazing. And so for those of you that think that we never landed on the moon because you saw a special on Fox, no, don't worry about it. The scale of the cosmos is just as amazing as its beauty. And so again, we'll go back to the moon and compare it to some other things. Here's the moon in a first quarter phase where you see it half illuminated on the right side. And that's when it looks very pretty through a telescope because the angle of the sunlight on those craters causes their shadows to be nice and long and deep. And you can see the craters best in that phase. And it looks so three-dimensional in a telescope. You can tell it's a sphere. When it's full, it looks flat as a dime. But when it's first quarter, you can tell it's a spherical little world. Here it is compared to the Earth. How about that? It just gives you a feel for how big it is. There's the Earth compared to Saturn. Now, astronomy is a wonderful lesson in perspective because in a telescope, Saturn looks like this tiny little gem. I mean, it is beautiful. Don't get me wrong, but it's tiny. You just want to stick it in your pocket. It's this beautiful little gem, but it's nine Earths across. And that's just the planet. The rings extend out even further. Those rings are trillions of tiny little moonlets that orbit around Saturn's equator. And they are stunningly beautiful. All the big planets have rings, but only Saturn's can be seen easily from Earth. Saturn's small potatoes compared to the sun. The sun's about 100 Earths across, over 100 Earths across. just to give you a feel for it. It's essentially a stable hydrogen bomb. It's fusing hydrogen and the helium in the core, and that provides enough power to supply us with energy for a very long time. It's not going to run out anytime soon. The sun is what we call a main sequence star. And basically, a main sequence star is sort of an ordinary run-of-the-mill star. And main sequence stars obey a particular formula such that if they have a given mass, that sets all the other properties of the star. It sets its size, its temperature, its brightness, its color, everything. And the sun obeys that rule. 90% of stars do. And then the other 10% are a little brighter than they should be for that. They don't follow that rule quite. But red stars that are main sequence are a little smaller than the sun and not as bright. And they are very common. They're called red dwarfs. There are a lot of red dwarfs in the universe. That's the most common type of star. We tend not to notice them as much because they're not as bright and they're harder to see. We tend to notice the ones that are bigger than the sun and brighter than the sun, which are rare, but they're there. Like Mintaka, for example, one of the stars in Orion's belt, and it's a blue supergiant. Very luminous, very, very luminous star. But there are stars that are bigger than that, like Canopus, for example. Now, you can't see it from up here, but if you come and visit us in Texas in February, you can see Canopus, because it's very far south, and so you can't see it from above a particular latitude. But there are stars bigger than that, like Antares, for example, which is one of the larger stars that we know of. Stars only get maybe twice that big, and there appears to be an upper limit on their size. Pretty amazing. It's several hundred suns across, and of course the sun is 100 Earths across. So if you do the math, that's really big. Yeah. Sometimes stars come in clusters. Not all of them, but here's what we call a globular star cluster. These are spectacular. There are a few hundred of these that orbit our galaxy. Our galaxy has its own set of globular clusters, and other galaxies have their own sets. It's about 100,000 stars packed into a relatively small area, cosmically speaking, only about 50 light years across, which isn't all that big for as many stars as you have crammed in there. They're absolutely magnificent. And you can see these in a small telescope. And I'm talking, when I say a small telescope, anything larger than, say, 6 inches across, which isn't that big. And you can get those, for a few $100. They're not all that expensive, and they won't depreciate like your computer will. So telescopes are a nice investment, a very fun investment. But there are hundreds of these, and you can see these. And if you have anything bigger than a 6-inch telescope, you can see the individual stars in them. They're beautiful. These are bright enough you can see them in binoculars, but you won't see individual stars. They'll look like a little cotton ball, kind of a little fuzzy object out there, but you can see them. And it just reminds me of that verse where the Bible says God calls them all by their names. God's got a name for each one of those stars. And that's just one globular cluster. Some of my favorite objects in the universe are called nebulae. That's the plural, nebula, which means cloud. But they're not a cloud of water vapor. They're a cloud of hydrogen and helium gas. Those are the two lightest elements, and they're the most common elements in the universe. Stars are made of hydrogen and helium as well, but stars are compact into a relatively small sphere. A nebula is spread out over a vast region of space. And if there are stars nearby, as there is in this case, they'll cause that nebula to glow, and you get the most beautiful, amazing colors in them. They're really stunning. This is part of the Tarantula Nebula there. And you can see there's a star cluster down here. And no doubt some of the stars nearby are causing that to heat up and glow. Very beautiful. And you can see these in a small telescope as well, although you won't see color. At least it's hard to see color, because when you use your night vision, you're using the rods in your eyes, and they're not color sensitive. So it'll look like a gray version of that, but it's still pretty. It's still quite lovely. Some nebulae are relatively small, only about as big as, say, our solar system, as opposed to the really big ones, which are light years across. But this particular one is what we call a planetary nebulae. These smaller ones are planetary nebulae because some of them are round and look like an out-of-focus planet. But there's no other reason than that. There's no connection with planets. It's where you have a star in the middle. You can see the star there. And it's ejecting gas, usually out the north and south pole of the star. And so you get these two-lobed structure there. They call that a bipolar planetary nebula because of the two poles. And so there are lots of planetary nebulae out there. Some of them bipolar, some of them are round. And it could be the ones that are round are also bipolar, but we might be looking right down the barrel. That's a possibility. We don't really know because we can't get another angle on it. We're where Earth is, and we're not going anywhere anytime soon. One of my favorites is the Ring Nebula. This was the first that I learned how to find. It is an easy find in a small telescope because God placed it right in between two guide stars for our convenience. It's one of the easiest ones for amateur astronomers to locate, and it's visible in the summer night sky not far away from the star Vega. And again, you can see the little star there in the middle. That star has died, so to speak. It has collapsed in on itself and become a white dwarf, so it's a tiny little star there. But it's blown off its outer layers into that lovely nebula. And it's so fun to see this in a small telescope. It's just this little glowing smoke ring. You're sort of expecting it to expand like we've seen smoke rings expand. And actually it is. It's just big. And so you don't notice it in your lifetime that it's not expanded very much. Really amazing. Again, you won't see the color, but it'll look like a gray smoke ring. And it's so weird because most of the places you point a small telescope, you just see stars and stars and stars and stars. And they're beautiful, but they're just stars. There's this one little magic spot where you will see a little glowing smoke ring, this little cosmic Cheerio suspended on nothing there, hanging there in space. Really, really stunning. All these things that we've looked at, all these stars and clusters of stars and nebulae, all of these are in a much larger structure called a galaxy. Our galaxy is the Milky Way. We're in it, so we can't see it, except, well, we can see it. We see it as a cloudy band in our night sky, the section of it that we see. But if we could get outside the galaxy, it would look something like that. That's the Whirlpool Galaxy, a galaxy very similar to ours. It has that beautiful spiral structure that you can see there. All kinds of galaxies in the universe, galaxies of tremendous beauty. There are galaxies of tremendous ugliness. Yeah. There are galaxies with large, mysterious arrows next to them. We still don't know what causes that. There are galaxies that have rings of stars surrounding the main portion of the galaxy. There are galaxies that look like flying saucers. That's a real galaxy. They call that the Sombrero Galaxy, and you can see why. It's got that dark dust lane around the equator of the spiral galaxy. There are galaxies that appear to be in the process of collision. That's interesting. Of course, the stars would just all pass right by each other because the distance between stars is enormous compared to the size of the stars. See, so that the chances of any two colliding would be remote. They'd all just pass by each other, not a problem. Clusters of galaxies, those little fuzzy specks you see there, those are galaxies, every one of those. As we got about as far out as we can see into space now, you find galaxy upon galaxy upon galaxy. These are not stars in this image. These are galaxies. Each one of those is 100 billion stars on average. Pretty amazing. And that's in a tiny little area of space up by the Big Dipper where they pointed the Hubble telescope for some time. Pretty amazing. All this spoken into existence by God in 6 days, according to the scriptures. In fact, if you think about it, most of this was made in one day, right? Because according to Genesis, 5 of the 6 creation days was God creating the earth, making it right for life and forming and filling it. He takes one day, the 4th day, and makes everything else, all these stars, all the luminous objects. And I love the way the Bible describes the creation of all these hundreds of billions of galaxies with hundreds of billions of stars. It's summed up in this little phrase, He made the stars also. Wonderful lesson in perspective, isn't it? It was just so easy for God to create 100 billion galaxies, and of course it was. He's God. It's not a problem for Him. The universe certainly declares God's glory. What about the basics of astronomy? Things that you would learn in a freshman level astronomy class. Well, you know, the Bible touches on astronomy. People say the Bible's not an astronomy textbook. I know that. Because, astronomy textbooks, we have to change them every few years as we learn that some of the things we believed were wrong. And the Bible will never have to be updated because God got it right the first time. And when it touches on astronomy, it's right because it's the Word of God. God knows how the universe works. He made it, after all. And so let's take a look at some of these. The spherical nature of the earth. You know, I've heard people say, well, you believe in creation? That's like believing in a flat earth. You know, if you're believing the Bible, I'm thinking, wait a minute, the Bible talks about the world being round. Isaiah 40:22 talks about the circle of the earth. And you might think, well, that could be a flat circle, but I think the Job passage is very hard to interpret that way. The Job passage has to be a sphere. It says God inscribes a circle on the face of the waters at the boundary between light and darkness. And that boundary is what astronomers call the terminator, where light stops or terminates. And it's always a circle because the earth is a spherical world. And it's on the waters because the earth's surface is mostly water. And so it's a wonderful description of the spherical nature of our planet. Now, if you look in most textbooks, they will credit Pythagoras with being the first person to come up with the idea that maybe the earth is round. It's hard to know exactly when, but around that time. And then Aristotle is usually considered the first to prove that that's so, from shadows of eclipses and things like that. But as far as I can tell, the Bible is addressing this topic before the secular experts of the day realized that. Isn't that interesting? The Bible's gotten them beat, but Isaiah's 700s BC, or Yeah, and then Job, we think, is the oldest book of the Bible to have been completed around 2000 BC. So isn't that interesting? The Bible's getting this right centuries before the secular experts of the day. You may have heard that Christopher Columbus was the first to come up with the idea that the earth is round. That is a myth. People already knew the world was round at the time of Columbus. He just thought it'd be faster to go that way, which turns out it isn't. So, but in any case, I'm glad he made the trip. People have known the world is round for some time. Earth is suspended in space. Job chapter 26, verse 7 says that God hangs the earth upon nothing. A wonderful poetic description of the nature of gravity. How about that? Might have been hard to believe when it was written. After all, most things don't hang on nothing, and that's not what the experts of the day taught. They taught that the earth was a flat disk and floated in water. And wouldn't that make more sense? Because after all, things float in water. We've seen that. But you can't hang something upon nothing. Well, you can't, but God can, and he did. And again, the description, which is perfectly accurate, God got it right long before the secular experts of the day figured that out. Pretty interesting. The expansion of the universe. The Bible describes God as stretching out the heavens like a curtain, spreading them out as a tent to dwell in. And it now appears that the universe is being stretched out. How about that? This was rediscovered by secular scientists in the late 1920s. The Hubble and others from observations of galaxies. It appears that all galaxies are moving away from all other galaxies, as if the entire universe is being stretched out or expanded. And, this verse would have been hard to believe when it was first written, because up until the 1500s, most of the astronomy experts believed the universe was static and unchanging. And any changes they did see, they attributed to atmospheric phenomena. They thought comets were part of Earth's atmosphere, for example. They thought the universe couldn't possibly be expanding. It's counterintuitive. You look at the universe tonight, it looks about as big as it looked last night. It doesn't look like it's being stretched out or expanded. And yet God was exactly right in his description there. Now, some people have asked, well, does this mean that there was a Big Bang? Because if you run it backwards, does that mean all the galaxies were together? And if you run it back billions of years, does that mean, does the fact that the universe is getting bigger mean it exploded into existence 13.7 billion years ago? The answer is no, right? Some of you are expanding a bit. That doesn't mean you exploded into existence billions of years ago. It just means you're bigger than you used to be. Apparently, God made the universe with some size, and he stretched it out since then. There's no reason to extrapolate back to a point. There's no guarantee that it was ever a point anyway. People have said, well, does this at least confirm the Big Bang? Because didn't the Big Bang predict that there would be this expansion and we discovered it? Doesn't that count as points for the Big Bang? No, because the expansion of the universe was discovered in the late 1920s. The Big Bang was invented in 1931. That was the first time anybody thought, well, maybe the universe coming from a point. It was developed to explain this expansion in a secular way, really. Now, the person who invented the Big Bang idea, he did believe in God, but he believed that God should be left out of anything science-wise, so he had a difference of philosophy from mine. Conservation of energy and mass. This one's a little more abstract, but I do believe that the Bible teaches that the amount of stuff in the universe, the amount of energy, or the amount of mass, is constant. Einstein tells us, by the way, energy and mass are really the same thing, measured in two different ways. We'd expect this on the basis of Scripture because all things were made by God. God made everything, that is. And we know that God ended his work of creation by the seventh day. The heavens and the earth were complete. And so he's not creating new things today in the universe. He's working today, but his work of creation is done, you see, until the new heavens and the new earth, the eternal state anyway. So we'd expect no new material would pop into existence. Does that bar creative miracles? Well, no. God can make an exception, but this is the general trend, you understand? The general trend is that God is finished with creation. And we'd expect that nothing would cease to exist because God upholds all things by the word of his power. And by him or in him, all things consist or hold together. So nothing's going to just evaporate either. And those two principles together are what we call conservation of energy or conservation of mass. Again, mass and energy being the same thing, basically. It's hard to pin down when these principles were discovered by the experts of the day. But usually James Joule is credited with the discovery of conservation of energy. He's 1800s. So again, the Bible's discussing these concepts, not in quite the same way that physicists would, but the principles are there millennia before The secular scientists rediscovered it. Isn't that interesting? Countless numbers of stars. The Bible describes Abraham's descendants as the stars of heaven and as the sand which is upon the seashore. And it says, which cannot be numbered for multitude. So the Bible is using this as a figure of speech to indicate a humanly uncountable number. Now, of course, we know God can count the number of stars and, in fact, has a name for each one of them. The Bible's clear about that. But from a human perspective, we couldn't possibly count the number of stars. It's a great analogy. It might have seemed like an inadequate analogy when it was first written, because the number of stars you can see with the naked eye is a few thousand. We estimate between 3,000 and, if you have superb vision, maybe 10,000 stars with your naked eye. And that's a big number, but it's countable. You could count to 10,000. It would be tedious, but you could do it. With the invention of the telescope, we pointed it at the Milky Way and realized, oh, wow, what we thought was that cloudy band is hundreds of billions of stars, and you cannot count to 100 billion in your lifetime. Can't be done. You don't live long enough. And that's just our galaxy, and we estimate there's at least 100 billion galaxies out there. And so we can maybe estimate the number of stars, but there's no way we could count them. It's a great analogy for a humanly uncountable number. The Bible got it exactly right. The experts of the day, well, they were wrong. There was a time when the secular experts thought there were exactly, I forget the number, I think it was 1,022 stars, because that's how many Ptolemy had cataloged in his work. And even though he never claimed that his list was exhaustive, there was a philosophy that everything worth knowing was known by the Greeks. And so if Ptolemy had only cataloged that many stars, there were only that many stars, despite the fact you can see more than that. So it really shows you how a philosophy can get in the way of observations if it's a false philosophy. So do you get the point? Have we learned a lesson of history? Have we learned that in the past, whenever experts of the day have disagreed with the Bible has always turned out to be right? And wouldn't it have to be if it really is the Word of God? What about today? Have we learned that lesson of history? Not everyone's learned that lesson of history, because you'll have people today that say, well, we know the Bible got it wrong here, and they're just setting themselves up to have egg on their face the way the experts of the past did. When God speaks on something, He's right. He's God. And so I want to now talk about a couple of issues where the secular experts today have not quite caught up to the truth of the Bible. One of those deals with the age of the universe. And my secular colleagues would say, no, 13.8 billion years for the age of the universe, and Earth's 4.5 billion years old. Well, the Bible indicates that's not the case. It indicates a much younger universe, a much younger Earth. And I want to show you that even today, there is evidence that lines up with what the Bible teaches about the age of the universe. Scripture teaches a young universe. It's clear that God created in 6 days, and it tells us what He did on each of those days. It's clear from context. Those are ordinary days because they're bound by an evening and a morning. Some people have tried to stretch that out into ages, but that won't work in the Hebrew based on the context, because you're bound by evening and morning, and there's a number with them and so on. Human beings are made on the 6th day, and from those genealogies you love to read before you go to bed, and so-and-so beget so-and-so, you can add up those ages, and it's no harder than balancing your checkbook, and it's a few thousand years. And the universe, by the way, that most of the celestial objects in the universe are made on day 4, and so that pins the universe at a few thousand years as well. That goes against what I was taught. I went through the secular school system, and I was taught billions of years, but there's evidence that confirms thousands of years. For example, the excess internal heat of the giant planets. Jupiter gives off twice as much energy as it receives from the sun. Okay, it's actually, it gets some energy from the sun, but it gives away twice as much. Okay, and you can't keep doing that forever, right? Because it's losing energy. You can't continue to spend away, more than you take in, unless you're the federal government, right? Well, Jupiter's losing energy, and it can't do that forever. The federal government can't do that forever either, by the way. Anyway, it's kind of like when you take a potato out of the microwave. It's nice and warm, and it radiates that heat out into space, right? But it can't do that forever because it's only got so much energy. It cools off. And for a potato, it doesn't take that long. Now, Jupiter is a much bigger potato. It's 10 Earths across, and so a few thousand years, it's not going to cool off very much. But if it were billions of years old, why isn't it an icicle by now? That's a problem for the secular view. The problem's even worse for Neptune, which gives off 2.7 times as much heat as it receives from the sun. Why is it so relatively warm if it's really billions of years old? And that's a perplexing dilemma for the secularists, but it makes sense given that they're young. These worlds are thousands of years old. The Earth's magnetic field. The Earth has a magnetic field that's caused by electrical current in the core, and that makes that magnetic field that surrounds us like a blanket, protects us from solar radiation and cosmic radiation and so on. And of course, you can make a magnet by taking a coil of wire and wrapping around, touching it to a battery. That's electrical current causes magnetism. And just like a battery runs down, Earth's magnetic field is running down. Earth's magnetic field is actually decaying. And we've been able to measure that over the centuries. And it's been decaying in a steady exponential decay. Now, we think during the flood year, because of all the tectonic activity, that would have disrupted those currents, and you'd have rapid oscillations in the field strength. But the total energy is just going to drop. So in terms of the total energy, it's just been dropping since creation. And we can measure that. We know from the last almost 2 centuries, we can measure the drop in the magnetic field. It's quite consistent with that exponential decay. It's exactly what we'd expect, which means you run it backwards, and at creation, it was a bit stronger than it is today. But you run it back 1,000,000 years, and it gets so strong, it rips the iron out of your blood. And that's not good. It would actually make life impossible if the magnetic field is as strong as would be required if it was even millions of years old, let alone billions. And so it's a big problem. My secular colleagues have to believe that it doesn't have this exponential decay, but that it's constantly oscillating back and forth, but there really isn't evidence for that today. Again, there might have been temporary oscillations during the flood year, but that just drains the energy even faster. It's not just Earth, but a lot of the other planets of the solar system also have these magnetic fields. Jupiter's would be bigger than the sun if you could see it. It's a very powerful magnetic field. And why is it still so strong if the planet's billions of years old? And I'm going to suggest it's because the planet's not billions of years old. It's thousands of years old. So it hasn't had time to decay yet. The planet Uranus. Uranus is tilted on its side as it orbits the sun, so it rolls around the sun, one way to think about it. And the magnetic field axis is stuck in the side like a bar magnet. It's not even lined up with the rotation axis, so the magnetic field would wobble as the planet rotates. Really strange. So the planet Uranus is just really messed up on a number of levels. And I think God did that just out of his creative diversity. But the magnetic field, I want to point out, the magnetic field is quite strong on the planet Uranus. In fact, it's strong enough you can have aurora borealis, northern lights. We have northern lights from time to time when Earth's magnetic field gets disrupted by solar radiation. And that's because of Earth's magnetic field. Well, that's northern lights. That little spot you see there on the bottom, that's not photoshopped. That's an actual image of northern lights on the planet Uranus. How about that? And it's much further away from the sun than we are. So that shows you the magnetic field has to be pretty substantial. And in fact, the Voyager 2 spacecraft, when it flew past the planets Uranus and Neptune, it measured their magnetic field and confirmed that it's consistent with thousands of years of decay. Isn't that interesting? My colleague, Dr. Russ Humphreys, who used to work for us at ICR, he's retired now, but he actually predicted the magnetic fields of Uranus and Neptune before they were measured by the Voyager 2 spacecraft. And he based that on their age of 6,000 years. He said, okay, based on 6,000 years of decay, here's what the magnetic field should be. The evolutionists thought that those planets are billions of years old, and so they thought the magnetic field should be virtually non-existent. Voyager 2 measured it. It was perfectly consistent with creation. How about that? Consistent with 6,000 years. That's real science right there. If you want to get the correct answer, you better start with the truth of God's word, rather than ignoring that history and relying on guesswork instead. My secular colleagues, perplexed by that, have said, well, there must be some kind of recharging mechanism that builds up the magnetic fields again. And if you've heard of magnetic dynamos, that's what magnetic dynamo models are. And they have problems of their own. One of them is that in the magnetic dynamo model, the rotation axis should be aligned with the magnetic axis. Is it? Not even close. Not even close. And they said, well, maybe that's just an anomaly. But when they flew past Neptune and it was doing the same thing, that kind of blew away that hypothesis. No, it's just consistent with thousands of years. Do you know the moon is actually moving away from the Earth? It's actually, and the reason it does that, the moon induces tidal bulges on the Earth. It pulls on the Earth's oceans, and that causes these tidal bulges. The tidal bulges get ahead of the moon because the Earth rotates faster than the moon orbits, and so the tidal bulges are always a little bit ahead of the moon, and they pull forward on it. And the counterintuitive thing is when you pull forward on something in orbit, it moves out. When the astronauts want to go into a higher orbit, they thrust forward, and that moves them out. It's a little bit strange, but if you've ever played with a gyroscope, you know that when things are spinning, they don't always act the way that your intuition would expect. But the moon is moving away at about 1.5 inches a year, so it's not a huge rate. If you run it backwards, that means 6,000 years ago, it would have been something like 730 feet closer to Earth. Not a big deal, considering the moon is 248,000 miles away. What's 730 feet among friends, right? But if you run it back billions of years, you got a problem. And you have to do the math right on this, by the way, because if you're running the movie backwards, as the moon gets closer, the tidal bulges get bigger, and it gets closer, and they get bigger, and it gets faster, you see. And it dives in at 1.4 to 1.5 billion years. So the Earth and moon would have been in the same place at the same time, and that's not good. And that happens at 1.4 billion years. And that may sound like a lot, but my secular colleagues believe the Earth and moon to be 4.5 billion years old. But they can't be older than 1.4 or 1.5 based on the recession rate. So it's just an indication that their worldview isn't correct. It doesn't make sense of the evidence. Comets are made up of icy material, and they orbit the sun in elliptical paths. They tend to go very far away from the sun, and then they come close and they whiplash back out. And when they're far away from the sun, their icy material remains icy material. When they come close to the sun, ice close to the sun, that can't be good. That icy material is blasted away from the nucleus of the comet. It's vaporized. And that's actually what forms a comet's tail. That's dust and other material and ice being blasted away by solar heat and radiation. So every time you see a comet, it's getting smaller. And by the way, that's why the tail always points away from the sun, regardless of what direction the comet's moving. I don't know which way this one's going. It might be going that way. Who knows? But the tail always points away from the sun for that reason. Every time you see a comet, it's getting smaller. It's losing mass. And it can't do that forever because it has no source of new mass. So it just gets evaporated away. And we estimate that a typical comet can last no longer than 100,000 years maximum. And some of them much less than that. I used the SOHO spacecraft in my doctoral dissertation. And one of the things it can do is it's designed to look at the sun. And one of the things it can do is it can block the actual sun and look at the outer atmosphere of the sun, the corona. And because of that, it's very good at spotting comets. Because comets get really bright when they get close to the sun. Hard for us to see them because of the solar glare. But SOHO is designed for that. And so SOHO has discovered over 1,000 comets. And I've seen them because I've used the spacecraft in my research. And I've seen comets that have gone behind the sun, and that's it. They're totally obliterated in one pass. They don't even survive. Interesting. So I know that they're short-lived. They can't last millions of years, let alone billions of years. Now, my secular colleagues believe the solar system's 4.5 billion years old. So why do we still have comets? It's kind of like if you walked into a sauna, nice and warm, and you see some ice cream cones there just starting to melt. You know they haven't been there very long, right? Comets are sort of the ice cream cones of the solar system. They are an indication of its youth. And by the way, my secular colleagues, they know that. They can do the same math I can do. They can calculate the rate at which the material is leaving, and we know the amount of material that's there in the nucleus. They know that comets can't last long. And so they figure there must be somewhere out there a comet generator that makes new ones, which they call the Oort cloud. If you've ever heard of the Oort cloud, that is an invented idea to try and explain why we still have comets in a solar system that's supposedly billions of years old. And the idea is there's this vast reservoir of potential comets out there orbiting way beyond where we can detect them. And every now and then one of them is thrown into the inner solar system, becomes a brand new comet. Pretty clever. There's no evidence of an Oort cloud, though. The only place you'll find it is in textbooks, but you won't find it in the actual universe. Not yet, anyway. My secular colleagues have a lot of faith in these kinds of things. Spiral galaxies. Now, not all galaxies are spiral. Some have more of an elliptical shape, but a lot of them are spiral. And these spiral arms rotate differentially, which means the inner portions rotate fast, as indicated by the arrows. The outer portions rotate slower. And so what you would think then is the galaxy would have to be twisting itself up. It's winding itself up tighter and tighter. That spiral structure would have to get tighter every rotation. And it turns out in 6,000 years, it hasn't rotated even once, and so it's not a problem. In fact, in these barred spiral galaxies, you can still have that bar structure there. It's just starting to wrap up a little bit in the middle there. In 6,000 years, not a problem. But if these galaxies are billions of years old, it'd be a huge problem because they'd be twisted beyond recognition. I recently wrote a computer simulation to use the actual velocities that we've measured in these galaxies to simulate what they would look like in 1 billion years. They're totally unrecognizable. you would not see that spiral structure. They look more like a, I'll have to show a picture of it at some point. I'll show you the results of the simulation, but it's really interesting. They wouldn't look anything like this. This looks like a young galaxy, and the interesting thing is all the spiral galaxies look kind of like that one. They have very distinct spiral arms. They don't have that real tight spiral structure that you would expect if they were really 10 billion years old. In fact, even after 1 billion years, you can't have spiral arms anymore, and they're supposed to be 10 billion years old. It doesn't work. And so my secular colleagues have to figure out ways to make new spiral arms as the old ones are wrapped up beyond recognition, spiral density waves and whatnot. But it's just easier to believe that the galaxies are the age the Bible indicates. That makes sense of their structure. You might notice, too, that these spiral arms have kind of a bluish tinge to them. That's because they have a higher proportion of blue stars relative to the central bulge. And blue stars themselves are an evidence of the youth of the universe because blue stars cannot last very long. They expend their fuel quickly. Blue stars are the most massive, most luminous, the brightest stars out there. And because they're giving out their energy so quickly, they're spending it like crazy. They can't last very long. They run out of fuel very, very fast. Now, they have the most fuel, right, because they have the most mass, but they expend it even quicker. They're kind of like the SUV of the star world. They have a big tank, but they get very poor gas mileage, and so they can't go very far. They can't last very long. The hottest, brightest blue stars can't last more than about 1 million years, and yet we find blue stars all over the universe. All over the universe. They're there. And my secular colleagues have to believe that, well, they obviously have formed there recently, but no one's ever seen a star form anywhere. Oh, you'll read about it in the newspaper. You know, they'll call this a star-forming region. Well, let me clue you in. What they're doing, they're not seeing stars form there. What they're finding there are blue stars that they know can't be billions of years old. And because they can't accept a recent creation, they have to say, well, apparently stars have formed there very recently, and so it must be a star-forming region. But nobody's actually seen a star form. And I think there are some very serious physics problems getting a star to form from a nebula. The idea is these nebulas collapse in on themselves, but gas normally doesn't collapse in on itself. Gas normally fills the container, right? When you walked into this room, you didn't hold your breath just in case all the air should go to that corner. You expected it to spread out. And aren't you glad that it did? Gas tends to do that. Gas pressure tends to be a lot more substantial in space than gravity. Now, once you make a star, its own gravity will keep it there because the gravity overcomes the gas pressure. But getting it to that state is a challenge, and it may even be impossible. So these are all just indications that the universe really is the age that the Bible says. And there are a lot more, but those are the ones that I think are some of the better arguments for which the secularists don't really have a good counter-argument. The uniqueness of the earth is another issue where my secular colleagues have not quite caught up to what the Bible teaches. Science confirms that the earth is unique among the worlds of the cosmos. It's designed differently than these other worlds. The Bible indicates that God formed the earth to be inhabited, and that's something that he didn't do apparently for the other worlds in the universe. The earth is specially designed for life. It's where God put the creatures that he made in his own image. It's where God himself came and died on the cross. Yeah, Earth is a special planet in the universe. In fact, if you think about it, Earth is 3 days older than any other planet in the universe, right? Because Earth's made on day 1. All the celestial objects, the sun, the moon, the stars also, were made on day 4. The Hebrew word kokab, which indicates star, would include planets as well. So everything else was made on day 4. Earth's special. It's unique. The other worlds of the solar system, they're amazing, they're beautiful, they certainly declare God's glory, but they're not designed for life. They don't have that unique life-housing property that the Earth has. One of the astronauts who walked on the surface of the moon referred to it as a magnificent desolation, and I think that's a wonderful description of the moon. It has a beauty to it, there's no doubt, but it's a desolate sort of beauty. It's not designed for life, not like the Earth is. Earth's neighbors, you got Venus there on the left, a little bit closer to the sun. You got Mars on the right, a little bit further away. Beautiful worlds. I'm glad God made them, but they're not designed for life, not like the Earth is. Now, of course, my secular colleagues expected to find life everywhere out in space because, after all, life's just a chemical accident, right? And when the chemistry's right, you get life. It evolves. And Earth's just one of the places where the chemistry happened to be right, and There's got to be other places out there where the chemistry happens to be right. And so you'll read in some of the older scientific literature expectations of finding life on Venus and on Mars. Some of the older sci-fis reflect that. You know, those old black and white sci-fis, The Outer Limits and things like that, where I think it was in Outer Limits where William Shatner lands on Venus and there are these weird creatures there and everything, and it's a lot of fun. But there were evolutionists who believed that Venus would be a tropical world with all sorts of interesting creatures on its surface, and they were free to speculate because Venus is permanently enshrouded in clouds. You can never see the surface. And so it's always nice to be able to speculate unfettered by inconvenient facts. Anyway, this was before we discovered the surface temperature of Venus is 900 degrees Fahrenheit. So yeah, you're not going to have life. And those clouds are sulfuric acid. So it's just a really nasty place and not designed for life. Now, it is designed for what it does because those clouds are highly beautiful and they make Venus very reflective, and that's why you'll see it in the evening sky. In fact, if you've been watching over to the west, that really bright star in the west, that's Venus. Got really close to the moon there last Sunday. I hope you got to see that. It's lovely. Mars, a little bit further away from the sun, that's also not designed for life. It doesn't have the nice protective magnetic field that Earth has. It doesn't have a substantial atmosphere. It has a thin atmosphere of carbon dioxide, which would be poisonous to us. It doesn't have liquid water on its surface, at least not in any abundance. It's not designed for life. Beautiful, but not designed for life. Kind of like Goldilocks and the Three Bears, right? You got these ones too hot, that one too cold, that one just right, because God made it for life. How about that? That's what we'd expect based on biblical creation. This raises the question, then what about extraterrestrial life? I've already alluded to that. My secular colleagues have always expected to find life in space. It's a big universe. Life's just an accident. It evolved here, probably evolved elsewhere where the chemistry was right. And that motivates a lot of the space program, unfortunately. Now, we've made wonderful discoveries despite that unbiblical motivation. But see, I would not expect on the basis of Scripture there to be life out in space. And I'll grant the Bible doesn't say directly that there's no life in space, but I think there's some theological issues you're going to have to think through if there's life out in space, especially if there's intelligent life out in space, right? Like you see on Star Trek. If there's Vulcans and Klingons out there, there's some theological issues you're going to have to think through, because do you realize the reason that we can be saved is because Jesus became one of us. He became a human being. He's a descendant of Adam. We're a descendant of Adam. That makes Jesus our relative. And so his blood can atone for us on the cross. We're all of one blood. Jesus is our kinsman redeemer. It's because he's related to us that he can save us. That is a theologically important concept that follows from biblical law. But the Klingons and Vulcans, they're out of luck. Lieutenant Commander Worf cannot be saved because he's not related to Jesus, you see. He's out of luck. And you say, well, maybe Jesus went to the Klingon homeworld and became one of them and died for them. No, the Bible says he died once for all. He was raised incorruptible, which means he's never going to die again. He's now and forever the God-man, not the God Vulcan or the God Klingon. And so you say, well, maybe the Klingons never sinned and never needed the Savior, but then they got a problem because they're living in a cursed, fallen universe because of man's sin. You see, it doesn't make sense. It's problematic. And this raises an interesting question then. It's called the Fermi paradox. Because the fact is, everywhere we've looked in the universe, we find it's designed to do what God has designed it to do, namely to bring him glory, but it's not designed for life. My secular colleagues continue to expect life in space. They continue to be disappointed. Fermi was a scientist who was very good at being able to do these quick calculations in his head or on the back of an envelope. You know, he could give you an order of magnitude estimate. And at one point he blurted out, "Where are they?" And people had to track him back. "What are you talking about?" He said, well, he'd done this little calculation in his head. If the universe is billions of years old, which he believed it was, and if life's just an accident on Earth, it probably evolved elsewhere too. And statistically, it probably evolved some places before it evolved on Earth, billions of years earlier, which means there should have been other civilizations that have come and gone and should have already colonized the galaxy, but the galaxy isn't colonized. And so where are they, was his question. Why is it we don't find any evidence of these past civilizations that have become spacefaring and colonized the galaxy? Where are they? It's a problem in the secular view. I want to suggest it's a feature for the biblical view. I find things like Star Trek very entertaining, but the biblical universe, the real universe, is the biblical universe. That's just the way it is. What about distant starlight? I want to spend some time on this one because this seems to be a big problem for a lot of people in terms of embracing what the Bible teaches. It really shouldn't be, but because of the weakness of our faith, sometimes we need a little more. Distant starlight really is not a problem for a young universe. What I'm talking about here is the fact that we can see these galaxies that are billions of light years away. And when I use the term light year, that is a unit of distance, not time. A light year is about 6 trillion miles, okay? And so when I say the universe is billions of light years in size, that just means it's really big. It doesn't mean it's old. People hear the word year in there and they think that, well, doesn't it have something to do with time? Well, a light year is the distance that light under normal circumstances would travel in 1 year. And so you'd think if these galaxies are billions of light years away, that it would take light, billions of years to get from there to here. And obviously the light has got from there to here because we see them. And so doesn't that prove the universe is billions of years old? And this has come to be called the distant starlight problem. But I want to give you what I think is a solution to this. There's actually a number of different ways to resolve it, which is interesting. And of course, God has access to solutions that we might not have even thought of or even considered. He's not bound by laws of nature as we are. But I do want to point out that some of the proposed solutions really don't work. And I mention this because sometimes people will come up and say, well, have you thought of this? And yeah, we've thought of that. And there's a reason it doesn't work. Some of the simpler solutions that people think of really have been investigated and they don't pan out. The idea that the distances aren't real, maybe the galaxies are all within 6,000 light years, it's not realistic. Even our own galaxy isn't within that distance. These distances, I won't go into all the details, but there's good science to support the fact that these are at incredible distances. The idea the speed of light was much faster in the past, I think that was very worthy of consideration. I'm glad that they looked into that, but I think there's compelling evidence that it was not faster in the past. The speed of light is linked into other properties in nature. It sets the relationship between, for example, between electric fields and magnetic fields. It sets the relationship between energy and mass. And so if you tinker with the speed of light very much in vacuum, it might not even make atoms possible. So we like the speed of light the way it is. Light was created in transit is one that I want to spend a little more time showing you why I don't believe that's a good idea for starlight. People have pointed out, well, the universe was made mature in the sense it was functional. Adam was made as an adult. He didn't have to grow up from a baby. And if you assume he grew up from a baby, you'd conclude the wrong age by looking at him. And that's true. That's certainly true. And so people have said, couldn't starlight be that way? Couldn't it be that God made the beams of light, the star, connecting the star to the earth? I think not. And the reason is because it would require God to create fictional images and movies. And I want to show you what I mean by this. Here we have supernova 1987A. There was a star in one of the Magellanic Clouds, and that little star right there in 1987 decided to blow itself to bits. Very sad, but it's a supernova. And so that star blew up. Now this star is in one of the Magellanic Clouds. It's over 100,000 light years away, let's say 170,000 light years away, something like that. And today, it looks like that. We see expanding star guts, what's left of the star expanding off into space. Now, if you say, well, when did that happen? Now, the secularists would say, well, 170,000 years ago, and the light just got here in 1987. And if you say, well, no, the reason we're able to see that is because God made the beam of light already on its way. When did this happen? Well, if you believe in light in transit, this didn't happen. It was just a picture that God made in a beam of light about 6,000 light years out that finally reached the Earth in 1987. If you believe in light in transit, this star never existed, that explosion never happened, and by the way, this doesn't exist either. These are just pictures that God put in a beam of light. And that really bothers me. It's not that I don't think that God has the power to do that. Of course he has the power to do that. The question is it consistent with his nature to do something like that? And I don't think it is. And I don't think God would create light with fictional information in it, as it were. And if you say, well, I don't know, I think he might, be careful, because how do you know I'm here right now, right? I mean, how do you know God isn't making the light 1 inch away from your eye, an image of me? Well, we hear you too, no problem. God made the sound 1 inch away from your ear. No, I don't think that God makes fictional pictures for us. So if light in transit is true, then none of these things have ever actually existed. But we do see these things. And I think there's a better answer anyway. One of the ones that I thought was a little more plausible, I think it's not the right answer, but I want to mention it because at least it deserves consideration. Dr. Russ Humphreys has pointed out that time can flow at different rates under different circumstances. Einstein discovered that. And Humphreys says, well, maybe that's the solution to starlight. Maybe that clocks on Earth tick slower than clocks in the universe. And I've chatted with him about this. It's an interesting model. I haven't seen the math work out in a way that actually solves distant starlight, though, but he continues to work on it, and it's interesting. I'm going to suggest that the solution may involve, I'm going to give you what I think the answer is. I think it involves the one-way speed of light, and that is the speed of light on a one-way trip as opposed to bouncing out off a mirror, a two-way trip. The speed of light in vacuum is 186,282 miles per second, very fast. But that is a round-trip average speed. And what I mean by that is if we wanted to measure the speed of light, here's how we could do it in principle. We could build a very long hallway, okay, 186,000 miles long. We'll pretend we have government funding so we can waste it that way, okay? And we'll put it out there. And so I'm going to stand over here on this end with my flashlight. I'll have a mirror at the other end, or another flashlight, either would work. And what I'm going to do is when the clock strikes noon, I'm going to send out I'm going to turn on the flashlight for just an instant, send that pulse out, and it'll reflect back. And as soon as I see the reflection, I'm going to look at the clock and see how much time has elapsed. And if we were to do this, we would find it takes 2 seconds for light to go out and come back. And so it's traveled a distance of 186,282 miles twice, and it's taken 2 seconds to do that. So the average speed is 186,282 miles per second. That's how you get the speed of light, and that's what we would find. Most people assume that it took 1 second to go out and 1 second to come back. But we don't actually know that, do we? All we know is the total time is 2 seconds. It could be, hypothetically, the case that the light zips out and takes all of 2 seconds. Maybe it takes no time at all for it to get out there, and then it takes all of 2 seconds to get back. That's a possibility. Or maybe it's the reverse. Maybe it takes all of 2 seconds to travel out there, and then it zips back instantaneously. And people have said, well, why? Is the mirror affecting it? No, it doesn't have to be the mirror. You could even use another flashlight out there. And when your buddy sees the beam, he turns on the return trip. It could just be that the nature of space is such that light propagates at a different speed this way than it does that way. You'd say, why would it be that way? Well, there are certain crystals that do that, where the speed of light's very different in one direction than another. And it could be that the vacuum of space is like that. The point is, we don't know. And you see where I'm going with this, because if this is the case, if light, when it's moving away from me, is slower, and when it moves toward me, it's much quicker than the average speed, that would solve the distant starlight problem, wouldn't it? Because I don't have to send light out to the galaxies and reflect it back. It only has to make a one-way trip. It only has to go from there to here. But so I'm hoping that this will be the case, but hoping for something doesn't make it so. We want to see if we can do an experiment to measure the one-way speed of light. So how are you going to do that? How are you going to measure the speed of light just on a one-way trip and not a round trip? Well, you can't use a mirror anymore. Instead, you got to use 2 clocks. You got to use one clock to tell you when to start the light pulse, and then another one to record when it impacts. Yes? So I'm going to stand over here. When this clock strikes noon, I send out the pulse, and my buddy's over there with his clock. And when he sees the pulse, he looks at his clock, and you're thinking that'll say, 1 second past noon. Yes? Well, I tried this in my office. I don't have a long hallway, but I have the distance between my watch and the clock on my phone. And I turned on the light right when it hit noon, and the light beam went over to the phone. As soon as the phone, lit up, I said, 12:05. It takes 5 minutes for light to get from my watch to the phone, right? No, you're not buying that? You see what I'm saying? When my clock hits noon, I turn on the light, it goes over, hits the phone says 12:05, 5 minutes. I made an assumption, didn't I? A faulty assumption. And that is, I assumed that the clocks were synchronized. Obviously, the clock on my phone is 5 minutes fast. I do that so I don't miss staff meetings. Okay, so only if the clocks are synchronized could you measure the speed of light this way. And by the way, they have to be exactly synchronized because the speed of light is very quick, whatever it is. We know it's quick. So if that other clock is just a little bit off, you'll get the wrong answer for the speed of light. It could be very wrong. You say, no problem. We'll make sure the clocks are synchronized. That turns out to be very difficult to do with clocks that are separated by a distance. Normally, the way we synchronize clocks is with a radio transmission. In fact, my watch does that. It receives a signal from the radio transmitter in Fort Collins, which is tied into the atomic clock in Boulder. And every night it receives that signal. I never have to set it. It's pretty neat. But it's not maybe exactly synchronized, right? Because that radio pulse actually takes a little bit of time to travel from the source clock to the receiver clock. Radio is fast, but it's not instantaneous. So, well, maybe what we could do, of course, if we knew the amount of time it took the radio pulse to travel from here to here, we could subtract that off. We could push that clock forward a little bit. Well, how fast does radio travel? You know the answer to that? It travels at the speed of light. Yeah. And so that's the very thing I'm trying to measure. That's the very thing I don't know is the one-way speed of light. We know radio travels at the speed of light because if I have a radio transmitter and a flashlight, they'll hit the wall at the same time. We know that. We just don't know what that speed is. My point is you'd have to already know the one-way speed of light in order to synchronize clocks by radio transmission. Now, I don't worry that my clock is maybe slightly behind the one in Boulder because I'm not trying to measure the speed of light. But if you're trying to measure the speed of light, they have to be exactly synchronized. Some people, for some reason, have thought if you put the radio transmitter in the middle, that'll solve it, right? Because then you send the radio pulse in both directions and both clocks are synchronized to noon at the same time. It doesn't matter what the speed of light is, but in fact it does because that presumes that the speed of light and therefore the speed of radio is the same in both directions. If it's different, then this clock gets set to noon first and that clock gets set to noon second. See, noon there and then noon there. And they're not synchronized. See, so you can't synchronize clocks that way. It doesn't work. One last resort. We'll synchronize two clocks in the same place. That's easy to do because you can see they're both reading the same time at the same time. Then we'll move one of them or both of them to opposite ends of the hallway. Yes? That should work, right? It doesn't, because according to Einstein, motion affects the passage of time. The very act of moving the clock has caused it to become desynchronized from its buddy. Now, it turns out there's an equation that can tell you how much the clock has become desynchronized, and you could compensate for it. And in that equation is the speed of light. Yeah. Isn't that interesting? It's almost as if God doesn't want us to know the one-way speed of light. Here's what the implication of this is. Apparently, it's impossible to synchronize clocks without knowing the one-way speed of light in advance. And it's impossible to measure the one-way speed of light without synchronized clocks. So you see, we're stuck in a permanent catch-22. It is fundamentally impossible to measure the one-way speed of light. It cannot be done because you need to have synchronized clocks, and the only way you can have synchronized clocks is if you already knew the one-way speed of light. It cannot be done. Now, when you have a catch-22 like this, it suggests that the question may be a bad question, a faulty question. And so I'm going to conclude that the one-way speed of light is not actually a property of nature at all, but is something that is a convention. A convention is something that we choose and we all agree to it and we stick with it and it works. Like driving on the right side of the road. That's a convention. We all agree to that and it works. But in other nations, they pick the left side of the road. And as long as they all agree to it, it works too. You see, that's a convention. It's not, it's, if we asked, well, what, in the universe, what is the correct side of the road to drive on? That question is meaningless because it depends on what country you're in. It depends on where you're at. Or how many, if I had a table that's, let's say it's 1 yard long or maybe it's 3 feet long. Which is it? Is it 1 or 3? What's the right answer? Is it 1 yard or is it 3 feet? What's the answer, right? It's both, isn't it? Well, should the number be 1 or should it be 3? Well, you tell me what you want. You will tell me if you're using yards or feet, and I'll tell you what the answer is. The one-way speed of light is like that. We get to choose what it is, and that tells us how to synchronize our clocks. And then when you measure the one-way speed of light with your synchronized clocks, you'll find it was whatever you chose. Yeah. Okay? So the lightning bolt strikes exactly in between these two clocks, and we're going to decide that the speed of light's the same in both directions. We can do that. We're going to choose that, and then the two clocks are synchronized. But if you want to make a different choice, you can do that too, and you can synchronize them differently. That light requires the same time to traverse the path A to M as for the path B to M is in reality neither a supposition nor a hypothesis about the physical nature of light, but a stipulation which I can make of my own free will in order to arrive at a definition of simultaneity. We choose the one-way speed of light, and that tells us how to synchronize clocks. And that quote is by Albert Einstein. Einstein recognized that the one-way speed of light is not something you measure, it's something you choose. Which means I can choose it to be something very different than what most people do. In fact, I can choose the speed of light to be infinite when it's directly toward me and half c when it's moving away. And the reason I pick those two values, it has to average to see. It has to average to the speed of light. That's the round trip speed. Okay, but you get to pick the one-way speed, and then the average will tell you what the return trip has to be. And it turns out it's 1/2 c if you make it infinite in one direction, because it's a time averaged. And one of the reasons I choose this is because it solves the distant starlight problem. But another reason is because all ancient cultures implicitly used this definition. They didn't subtract off light travel time because they didn't know what the speed of light was. When you saw something, that's when it happened. And so I'm going to suggest that the distant starlight is solved if we use this. I'm going to call it an anisotropic, which means different directions, anisotropic synchrony convention, or ASK. Using the anisotropic synchrony convention, light takes no time at all to get from distant galaxies to here. And according to Einstein, I'm free to synchronize clocks that way. And the distant starlight problem, therefore, is solved if the Bible's using that convention too. And so that's really the only issue. Is the Bible using this anisotropic synchrony convention, or is it using Einstein convention, or is it using something else? It's using some convention because it's talking about time. So there's some convention there. I think the Bible is using this anisotropic synchrony convention. I'm going to show you why. Well, I already mentioned one reason. All ancient cultures used that. And the Bible is meant to be understood by everybody, not just by modern physicists. But if you take a look at Genesis 1, 14 and 15, then God said, "Let there be lights in the expanse of the heavens to separate the day from the night, and let them be for signs and for seasons and for days and years." And later we find this is the sun, the moon, and the stars also, the greater light, the lesser light, the stars also. He says, "And let them be for lights in the expanse of the heavens to give light on the earth." And it was so. It's that last little phrase, "and it was so." What was so? Well, they gave light on the earth. You see, God created them to give light on the earth, and apparently they immediately did, and it was so. That suggests to me that the Bible's using this anisotropic synchrony convention whereby light reaches the observer in no time at all. And according to Einstein, that is a legitimate convention. And by the way, I'm not suggesting that the alternative, that the speed of light is the same in all directions, is wrong, because that's like saying a table, it's wrong to say it's 1 yard long. It's actually 3 feet. They're just two different ways of measuring things. And so I'm going to suggest that the convention the Bible uses allows light to get here instantaneously. It's not a problem. There could be other answers to that, but this is one that works and nobody's been able to refute it, so I think it's a pretty good model. Well, we've seen that the glory of the Lord's revealed in the heavens. We've seen that the Bible's right when it speaks on the basics of astronomy. We've seen that the Bible is right when it talks about the age of the universe, and there's evidence that lines up with that. We've seen that the earth is unique, as the Bible indicates, and we've seen that starlight is not a problem for thousands of years. In fact, it can get here instantaneously if you're using the anisotropic synchrony convention, and there are other ways to do it as well. There are a number of resources we brought with us out in the back table there. Please avail yourself of these. It's hard to get good resources on astronomy from a Christian perspective, and so take advantage of them while they're here. We have Taking Back Astronomy is my book that covers much of the topics that I talked about today and a few that I didn't. And it's a beautifully illustrated book. It's got full color pictures and everything, and some people have thought it's a kid's book because of those pictures, but it's not. My theory is adults like pictures too. And pictures are one way that the universe declares God's glory is by its beauty, so I think you'll really enjoy that. Stargazer's Guide to the Night Sky is one of my latest books. This is basically how to enjoy the night sky better. If you've ever wondered how to, what constellation is that, and where's Saturn this time of year, and should I get a telescope, and if so, what kind should I get? All that information is in this book, star charts, what you can see in a telescope, what you can see naked eye. You say, I don't have any intention of getting a telescope. It'll still work for you. It'll still show you what you can see naked eye. Created Cosmos, this is the planetarium show I wrote for the Creation Museum. We have it on DVD and Blu-ray out there. It is really exciting. It takes you on a journey through the universe, all from a biblical perspective, and shows you how it confirms God's glory. Now, I didn't talk about these issues tonight, but if you wanted to really defend the Christian faith effectively, there's a book I've got called The Ultimate Proof of Creation, and it's going to show you how you can, how to think properly, really, and how to debate these issues in a friendly way with your secular friends, and how you can demonstrate beyond any doubt that the Christian worldview is correct. It really is an ultimate proof of creation. Discerning Truth is on how to spot logical fallacies in evolutionary arguments. Evolutionists commit errors in reasoning, fallacies, left and right, and we let them get away with it, and we really shouldn't for their own benefit. We need to politely point out that these are fallacious, the arguments they're using. We have a book called Creation Basics, and there's two versions of it. There's the Guide to Creation Basics, which is the sort of the very, very layman version. And there's called Creation Basics and Beyond, which goes into a little more depth. And those are fantastic resources. I believe we have both of them out there. We have a free publication too, Acts and Facts. Now, how many of you are already getting Acts and Facts magazine? Oh, not nearly enough. Okay, the rest of you need to repent from that sin and sign up. It is a free magazine, and it is a wonderful magazine. It's a monthly journal through creation, really. And in fact, I'm doing a series on the solar system, so you won't want to miss that. And just sign up on the sheets in the back, and we'd be happy to give that to you. There's no catch. We're able to do that because of our generous donors. Check us out on the web. ICR is our website, Institute for Creation Research, ICR.org. And we have a student website as well, youroriginsmatter.com. You might want to point students to that one. It's a great resource where they can come and ask questions and everything. I have a blog, too, that some people get a kick out of, jasonlisle.com. I put some interesting articles up on there from time to time. So thank you very much.